can just focus on doing problems, right? And then I will just come in once in a while. But we're basically going to do a quick review of one-step, two-step, multi-step equations, and then graphing chapter 2. So you can just focus on doing problems, right? And then, okay, well, welcome everybody to our series where we're going to do math problems live with Mr. Chinonso and Mr. Michael. We are from the Counting the Calculus Squad, which is a math program that teaches counting the calculus and all math concepts to help children become proficient in mathematics and do very well at it and love it also. I'll be introducing our guest lecturers today in a second. My name is Amos Tarfa. I'm a medical physicist and math and science curriculum writer. I am I wrote the Counting the Calculus curriculum framework over the last about 12 years. And basically the idea of Counting the Calculus is, can we take every textbook of every country and put it into one book? And then a child can take that one book and say, I'm gonna just learn. Now, so this gentleman, Leonhard Euler, did something like that back in the 1750s. And that's what we've also done now for our students. What that means is that regardless of your age or grade level, all you need is to get yourself a book that has all the topics, so that if you're struggling with fractions, you go back. If you're struggling with algebra, you go back to where you need to go, but it's all in one. So Counting the Calculus is aiming to transform math education globally. We believe that every child can do math, and we believe children can go far in math. But the systems that have been built are not allowing children to reach their full potential in mathematics. Our goal is to solve that. And so by the grace of God, we want to help 1 billion children to do calculus with confidence. But in order to do calculus with confidence, you have to have a strong foundation. And so many children don't have a strong foundation. So how are we going to solve the problem of the foundation in mathematics? The way we're going to solve that is we're going to start from scratch, right? We already have that ready for you, and we're going to put that in the chat. So if you visit our website, countingtocalculus.org, you can actually visit our Teachable site, and then we already have the videos recorded for addition, subtraction, multiplication, and division, fractions, decimals, percents, ratios, and proportions. All those videos are ready for you, and they're free. You can take that and start using that to support your students. But today we are going to talk about algebra. What we are going to do is we're going to start with a quick review of one-step equations, two-step equations, multi-step equations, and equations with letters, right? Because sometimes you have an equation and it has letters. How do you navigate that, right? So that's the plan. We're going to do one-step equations, two-step equations, multi-step equations, and equations with letters. And so Mr. Chinonso and Mr. Michael will do a quick review of that, and then they're going to dive right into graphing. Graphing is one of the most important topics in mathematics. And so we're going to look at how do we graph lines? How do we use table of values? How do we find if lines are parallel or perpendicular? We're going to start today, and we'll see how far we get. And then tomorrow we'll continue, God willing, all the way till Thursday. We're going to be working through problems. I want to say one more thing that is very interesting. It's a paper and a book that I'm going to be writing this year. I believe math education has been solved. I actually believe it with all my heart. What it means is that back in the day, if you wanted to learn certain things in mathematics, you had maybe one particular textbook. Like for me in Nigeria, we use New General Mathematics. So if you were done with this textbook and you understood how to do everything in this textbook, you couldn't just go to the next book. You had to wait till the next year. What happens when all the textbooks and all the resources and all the topics in all the books are now available to children at any time they want? That changes the story. But I think we're still living as though that hasn't happened, but it's already happened. I believe education expired September 4th, 1998, when Google became a thing. Why? Or when Google started growing? Because information is readily available. The problem is not information. The problem is inspiration. And so at the Learning Institute for Excellence in Counting the Calculus, we want to inspire children to love to learn. This is one of the ways we're going to do that. It's not just by talking about helping them to love to learn, but showing them. Your children can do 2 to 3 years of math ahead of time. Like your children can keep learning at their pace and covering a lot of ground. But again, the system sometimes, I think, is hindering them from reaching their full potential. Let's help every child reach their full potential. So welcome to the series. We are also doing a launch. This is a launch officially into Nigeria, Kenya, Rwanda, and Zambia, Angola, Cameroon, Ghana, and South Africa, and all other African countries that are willing to invest in helping their children reach their full potential in mathematics. And what do I mean by this is a launch? We will now be teaching classes live for students in Africa at the same time we're teaching classes to our students in America. So students from around the world will be doing math problems, growing and learning and just hopefully flourishing in their journey in math. So I want to welcome Nigeria, especially to this call, because in Nigeria now, we have our packages ready to go. You can visit our website, sparklearn.net, sparklearn.net, and I'll put that in the description as well. But what that means is that if you're in Nigeria and you want your child to become very good at mathematics, no matter what anybody has ever told you, your children can become very good at mathematics. How do I know that? Because when Leonard Euler wrote this book, or when he was dictating some of the content that will be associated with this book, he was dictating it to his tailor because he had gone blind. And even though this tailor was not a trained mathematician initially, that tailor became really good at math. That tells us that the methods that are used matter a lot. And the first chapter in his book, Elements of Algebra, which is available on our website for free, the first chapter in his book is What is Mathematics? What is addition is the second chapter. What is multiplication and division? The greatest mathematician by many counts, is writing a book on mathematics, and he's going systematically. Parents, your children have so much potential in math. And even if they're the best in their school, they even have more potential than you might know. Let's get them to become the best they can be. And therefore, I want to welcome Mr. Chinonso and Mr. Michael. So let me start with Mr. Chinonso, quick introduction, and then Mr. Michael, and then we'll go from there. Welcome, Mr. Chinonso. How are we doing today?
Excellent. Thank you, Mr. Amos. Hi, everyone. It's my pleasure to be here. And of course, as I've been introduced, my name is Chinonso Lekwa, and I'm a math tutor. Over the years, I've tutored and prep students who are preparing for the SAT. And I'm excited to walk students through some of the questions we'll be having today. Thank you so much, Mr. Amos.
Thank you, thank you. And you guys will get to know Mr. Chinonso as time goes on. He's helping us with different ideas and programs, and his organization in Nigeria, GIVA, is one that we're partnering with to see education transformed in Nigeria and beyond. Mr. Michael, can you give us a short intro? Who's Mr. Michael?
Yeah, thank you very much, Mr. Amos. Thank you, Mr. Chinonso. It's a privilege to be here to help students get better in math, to help them scale their math potential. So happy to be here to join this live stream. And also, I'm a math tutor. I help students in the quant section of the SAT and GRE. And currently, we are preparing students for the Quantitative Calculus squad. Thank you.
Well, thank you so much. I'm going to hand over now to Mr. Chinonso and Mr. Michael. Help us learn some mathematics. Over to you guys.
All right. Yeah, thank you so much. Okay, so thank you so much, Mr. Amos. And so Mr. Michael and I will be walking through the questions, and we'll take these questions in turns. And so I would love to take the very first question we have here, and it's a simple linear equation with one step. So it's one-step equations, and what this means is you just take one step to solve. So let's take, for example, the very first question we have here. Okay, sorry, my pen. Okay, so the very first question we have here, we have v plus 9 is equal to 16. So to solve this particular linear equation, what you want to do is to make v, which is the unknown, to stand by itself. So you want to perform the same operation that you would perform on the right-hand side to the left-hand side. So when you have an equation, you can always perform the same operation on both sides of the equation to ensure that you have a balance. So to isolate v, what we want to do as mathematicians is to subtract 9 from both sides of this equation. So I want to subtract 9 from both sides. So this, I'm left with v is equal to, now 9 minus 9 is of course 0, so that fizzles out. And then I'm left with 16 minus 9, which is 7. So my v is equal to 7. So this is how to solve a one-step equation. So Mr. Michael, I think you can help us solve the next one.
Yeah, thank you very much, Mr. Chino. So that was very, very straightforward. I mean, guiding in the lower grade can even understand what is happening here. So I would just take question two. Question two. Question two is 14 is equal to b plus 3. Okay, so this is a linear equation and they want to find the value of b. And for us to do that, it's not possible for us to add 3 to b. You can't add 3 to b. It's not possible. They don't add up, right? So what we need to do is to isolate b and take 3 to the other side of the equation. So how do we even do that? We need to add the opposite of 3 to both sides of the equation. And what the plan is to just get rid of 3 from the right-hand side. Maybe you don't know. Every time you see an equation, the first guys before the equality sign, they are called the left-hand side. And those people after the equality sign are called the right-hand side. So maybe when I'm talking about the sides, you understand what I mean. So we want to get rid of 3 from the right-hand side. To do that, we just add the opposite of 3 to both sides. So what's the opposite of 3? That is minus 3. So we're going to subtract 3 from both sides. And if we do that successfully, you will discover that in the right-hand side, the b will just cancel out, and then we have b all by itself. And that's the reason why we are subtracting 3 for both sides, so that we can have b all by itself. So 14 minus 3 will give us 11. So the answer to question 2 is 11. So if 11 is equal to b, it's the same thing as b is equal to 11. Thank you.
Perfect. Thank you so much, Mr. Michael. So we'll take a few other questions. So I think I can take question 3. Okay, so question 3, what we have is x minus 11 is equal to negative 16. So again, we want to get the value of x, and as we've established in our previous solution to question 1 and 2, you want to get rid of the numbers associated with the unknown. And to do that, you want to, for example, you have 11 here, negative 11. You want to use the opposite of it. So that's a plus 11. So you add plus 11 to both sides of the equation. So for an equation, you could see it as something that has a balance. So to maintain a balance, if you do something on the left-hand side, this is the left-hand side, you make sure you do that same thing on the right-hand side to make sure you maintain the balance. Otherwise, you no longer have an equation. So what I want to do is I want to take out this negative 11 from the left-hand side, and I want to keep x to stand by itself. So what I want to do is I want to add 11 to both sides just to get rid of this negative 11 that is on the left-hand side. So I want to add 11 and then add 11 here too. So that leaves me with x, and then negative 11 plus 11, so they cancel out. So I'm left with x is equal to, so negative 6 plus 11, which is negative 5. So the solution to question 3 is negative 5. And so what that tells me as a mathematician is that if I add negative 5 to if I add negative 5 and negative 11, I would get negative 16. So when you see an equation, there's always a balance. So you're looking for a value of x that add with negative 11 to give me what I have on the right-hand side. So that's an easy way to understand mathematics. All right, thank you so much. Over to you, Mr. Michael.
Yeah, thank you very much, Mr. Chinoso, for that one. For those of you who are just joining the live stream, we already have recorded videos for one-step equation. This is more like a brief overview on what one-step equation is all about. So right about now, we're going to be moving to the next section in this chapter. So you're going to be moving to two-step equation. We'll do that real quick and we'll move on to graphing. So if you're just joining this live stream, you're welcome. Subscribe to the channel. You're going to see us same time every day from now to Friday. And like I already said earlier, we have all of this video on our website, counttoCalculus.org. You can always go there and check, and you see all of these videos are right there. So with this, at this very point in time, we'll move on to the next section, which is two-step equation. All right. Yeah. So you can see now on your screen, we have the two-step equation on your screen. And I will just start with question 1, and I think Mr. Chinoso will do the next one. And thereafter, we'll move on to the next chapter. All right, so guys, this is 1.2 and two-step problems, two-step equations. So I'll take the very first question, which is question 1. I have 5 plus n upon 4 is equal to 4. Now, when you have equations like this, the mission here is to get the value of n that satisfies this given equation. That's the mission. If you can do that by just looking at this equation, you're good. Let me see if I can find the value of n that will satisfy this given equation without even solving. That is, we call it trial by error. If n is 4, you just imagine if n is 4, you're going to have, I'm just guessing, okay? If n is 4, I'm going to have 4 over 4, and 4 over 4 is 1, right? So 5 plus 1 is 6. So I see that gives me 1 unit ahead of what I'm expecting. So if I make n to be minus 4, that is going to be, if I make n to be minus 4, that's going to be 5 minus, oh, sorry, I think my pen is just writing all by itself. The pen is now a teacher. So if I make n to be minus 4, I have minus 4 over 4, and that will give me 5 minus 1. So that is exactly 4. So that means the value of n that will satisfy the given equation is minus 4. But now let's solve this problem algebraically and see how to get that value of n to be minus 4. So the first thing I want to do is to get rid of 5 from the left-hand side of this equation to the right-hand side. And how do we do that? We add the opposite of 5, the additive inverse of 5. So the additive inverse of 5 is minus 5. So we subtract minus 5, we subtract 5 from both sides, So when you do that, you see that the 5 here on the left-hand side would just fizzle out, and you'll be having n over 4 in the left-hand side, and in the right-hand side, you'll be having 4 minus 5, which is the same as minus 1. Now, when you have this kind of equation, you can see in the left-hand side, we have a fraction, and in the right-hand side, we kind of have a whole number. I would like to make everybody the same. So if I write minus 1 as minus 1 over 1, I'm sure you know that is not, I've not changed anything. It's just the same thing, because every number can be written as that number over 1. Amen. If I have 100, 100 is the same as 100 over 1. If I have A is the same as A over 1. Every number can be expressed as that number over 1. In fact, 1 is called the universal divisor. So when we make this true, we can just go ahead and cross multiply. So we multiply n to 1. So n times 1 will give us n. And when you multiply 4 to negative 1, you get negative 4. So that is the value of n that will satisfy the given equation like we predicted earlier. So thank you very much, Mr. Chinonso. Over to you.
Yeah, oh, wow, that's quite impressive. I'm glad you explained it the way you did. So when we have an equation, what we're looking for is the value of the unknown that would satisfy the equation, and that's pretty very straightforward. So I'll go on to solving question 2, and so question 2 says negative 2 is equal to negative 2m plus 12. And so the mission here is to look for a value of m that satisfies this equation, such that when you multiply that value by negative 2 and add it to 12, we would have negative 2, which is what we have on the left-hand side. So this is the left-hand side, and this is the right-hand side. So to solve these, the first thing I want to do is I want to try to isolate the term that has the unknown. And to do that, I want to subtract negative 12 from both sides of this equation. So this is negative 12, and I'm also subtracting negative 12 here. So negative 2 minus negative 12 gives me negative 14, which is equal to negative 2m on the right-hand side. And then negative 12, positive 12, so well, I think I should just go on to add. Yeah, because adding is what takes this out. So just a minute. So I just have to change my operation. So you see, as a mathematician, you want to observe, you know what you want to achieve, and that's what will guide your procedures. So what I want to do is, for example, add 12 to both sides. So for example, I have here, so 12 minus 12 gives me 0. So a 2 minus 12 gives me negative 2 minus 12, that's negative 14. Well, that's still the same thing, 2m, and then this goes out. So to solve for m, what I want to do is I want to divide through by negative 2, just to ensure that m stands alone. So you want to divide through by negative 2, and then once you do that, you find that this cancels this, the negative cancels the negative, and then you're left with 14 divided by 2, which is 7. So 7 is equal to m is our solution. And then we can then rearrange we can take m to the left-hand side, and then the constant, that's 7 to the right-hand side. So that's m is equal to 7. This is the same thing. So when you have equations, you can move the terms on either sides and change their positions without affecting it. It's only when you have an inequality that you have to reverse the sign. All right. Thank you so much. Ms. Michael, over to you again.
Yeah, thank you very much for that one. That was really clear. And for those of you who are just joining the live stream, this is Counting to Calculus Squad. We are here to help you get so better in maths. That is the mission. We want to help you scale up your maths skills. So if you're just joining, kindly subscribe to this channel and put on the notification bell so that whenever we go live again, you'll be the very first person to be notified. Yeah, like we also said before, these videos here, they're already on the channel. You can check on the comment section or check the description of this video. You're going to see our website. And when you click on that website, it will take you directly to our page where we have all of these videos documented. And again, if you need the one-to-one tutoring, maybe you're preparing for the SAT, GRE, IGCSE, any kind of math at all, just reach us on our website and somebody will be right there to walk you through all the steps you need. So right about now, we're going to be moving on to the next section. Like I said, this is more like a brief overview on what one-step and two-step equation is all about. And you can see all we'll be doing here, we'll be learning how to solve linear equations. So what we are going to be doing next is we're going to also learn how to graph this linear equation. And that will take us to the next chapter of this book, which is chapter 2, and that is graphing. So just give me 1 minute. Let me take you all to that chapter. So this is what we're going to be doing now. We're going to learn how to graph those linear equations. And like we've already learned how to solve them, let us also learn how to graph linear equations. Let us learn how to locate points on the Cartesian plane. Okay? So again, if you're just joining, kindly go get your writing materials because you're going to have a lot of things to write and you don't want to miss any of these things you're going to be sharing here. So let me start with the very first question in this practice. Now, the first thing we want to learn here is we want to learn how to graph or how to locate points on a Cartesian plane. Now, every point on a Cartesian plane has two coordinates. Before we even start talking about coordinates, let me explain what a Cartesian plane is all about. You know this stuff when you have vertical lines and you have horizontal line cross each other, that is called the Cartesian plane. Now, this horizontal line is called the x-axis, while the vertical line is called the y-axis. Now, the point where these two lines intersect is called the what? The origin. So if you have these questions, when we ask questions, just for that, so that we are interactive in this class, you want to put your answer in the comment section, okay? And of course, we can go ahead and check the person, the student who is getting these things correctly. So the point where these two lines intersect is called the origin. Take note, I just made mention of very important term in this section, which is intersect. So let's move on from here. Now, if I have the y-axis here and I have the x-axis here, let me tell you how we calibrate these x and y-axis before we start doing this question by this side. So on the x-axis, this is 0. Let's say here is 1, here is 2, here is 3, and so on. You know, this is a line, it continues in both directions. So by the left, you have the negative numbers, -2, -3, -4, and so on. Okay. Now let's go to the y-axis. Sorry. On the top, we have the positive numbers. Let's say 1, 2, 3, and so on. And just below it, we have -1, -2, and so on. I know this is not the best drawing, but I'm sure you're going to learn from this stuff. Okay. Yeah. So quickly, if I have this plane, this is a plane, okay? If I have this plane and I want to figure out what each point, I want to figure out the coordinate of each point on this plane. Let me just give us a random point. Let's say, let me use a different color. Let me use black. So I have this point here on this Cartesian plane. Now, how do we figure out the coordinate of this point? This stuff we are learning is going to help you. Maybe you want to go into working with Google. Google needs this skill because somehow they can always track you anywhere you are on the surface of the earth. They use this system. This coordinate system is what they use, but they use it on the earth, which is called the latitude and the longitude. So it's very much applicable in real life. So if you want to work with Google, you want to work with all these companies that do tracking and the rest of them, you need this skill. You get it. So now let me show you how to locate this, how to get the coordinate of this point on this plane. Now, the first you want to do, the coordinates are always written in this form x comma y. In math, we always follow order. X comes before y. That's how we have the x comma y. So for us to write this point in coordinate form, we trace it down to the x-axis, and you can see that is 1, right? And we trace it down to the y-axis, and that is 3. So that's going to be 1, 3. So that is simple. That is just how to locate any point on the plane. Okay, I think that is pretty clear. So let us go right into question 1 and start solving. So 1 second, let me take this screen a little bit. Okay, I think it's good here. So this question is saying state the coordinates of each point. State the coordinates of each point. So let's start with the very first one. Is there any A here? No A. So let's start with B so that we kind of follow up correctly. So I think B is the first alphabet here. There's no A. Okay, so let's start with B. So if I want to locate if I want to state the coordinates of point B, they call this stuff points, okay? And every point has coordinates X and Y. So if I want to get the coordinates of B, so what do? You want to trace it to the X-axis and then to the Y-axis. And if you look at this stuff, let me just let me calibrate it so that we can all see it. This is 1, 2, here is 3, somewhere here is 4, 5, 6, 7, and so on, okay? And here is the negative, here's the 0, the origin where the two lines intersect. Here is -1, -2, -3, and so on. So if I want to get the coordinate of B, that will be 4, because when I trace that to the x-axis, I got 4, right? And to the y-axis, that will be, yes, -1, -2, and -3. Right on top of it is the positive number. We have 1, 2, 3, 4, and so on. You all know what I'm doing, right? Yeah. So we trace to the x-axis, we got 4, and to the y-axis, that is -3. So the coordinate of point B is 4, -3. So I think I'll leave Mr. Chinonso to do the other ones. Thank you, Mr. Chinonso.
Yeah, thank you so much, Mr. Michael. So I'm sure the students have been able to see that each point in the Cartesian plane has a coordinate which comprises 2 points. So the X and then the Y. So we report coordinates as X, Y. So Mr. Michael, I know you've been able to give us the points. And so where exactly would you want me to continue from here? Or would you want us to move to the next question?
Okay, maybe you can just show them how to get some of those points, maybe point H and maybe point E. I think E is unique. E is actually on the x-axis, so I think we should just point and some other one.
Okay, so great. So I think we can look for the coordinates of point H and E. So looking at these and with the explanation that Mr. Michael has given to us, to get the coordinates of point H, what you want to do is remember that in reporting the coordinates of any point, you want to report in this order. The X coordinates comes first before the Y coordinates. So looking at point H, you want to trace its value to the X axis. And then this is the X-axis, while this is the Y-axis. So you want to trace its X component. And looking at this, it corresponds to a -1. So this is, so everything you have on the left side of the Y-axis are negative values, and everything you have by the right to the Y-axis are all positive. So H has a negative X component. So this is, we're talking about point H. Of course, we look at E. So looking at this, we can tell that the negative, the X coordinate here is -1. And then we put our comma, and then we want to get the Y coordinate. So we want to count. Also, everything you have below the X-axis is negative, and everything you have above the X-axis is positive. So we want to count. So that's 1, 2, 3, 4. So that's -4. So the coordinate of point H is -1, -4. So coordinates help us locate points on the Cartesian plane. And again, points on the Earth are also represented using coordinates, where we use the lines such as the equator, and then the lines of latitude and longitude. So that gives us an understanding. So every point must be reported with a pair. So the x coordinate and then the y coordinate, where the x coordinate comes first and then the y coordinate comes second. So to get the coordinate of point E, which appears to be on the x coordinates, we know that when Mr. Michael was talking, he talked about this point being the origin, and the origin has a coordinate of 0, 0. So what that means is that at this point, the x value is 0, and then the y value is also 0. Then one thing you need to also know this is that on the x-axis, the y value is 0. So at this point, our y value is 0 because this is positive 1. And then what we have just below it, the unit just below it is negative 1. So it's by reasoning, we can tell that this point has 0 on the y-axis. Likewise, on the x-axis, this is negative 1, and then this is positive 1. So we can just deduce and also tell ourselves that this point here, which is the y-axis, so the y-axis cuts the x-axis at 0. So it therefore means that the y-axis here is 0. But we need to also get the x component. So the x component is, you need to count. So this is 1, 2, 3, 4, 5. And it's on the left side of the y-axis, so it's negative. So the x component here is negative 5. And then the y component is 0. So this is how we report the coordinates of any point on the Cartesian plane. Yeah, thank you so much, Michael.
Yeah, thank you for showing us how to report points on the Cartesian plane. So if you're watching and maybe somehow some stuff are not really clear, you need more explanation, or somehow you need one-to-one tutoring. Like I said, go on the description of this video. You're going to see our website. Click on the website, and that will lead you straight to our admin. I mean, they are going to walk you through the whole process of meeting a tutor. Okay, and all these videos, they are recorded already on our channel, so you can go ahead and watch the videos and get more better. So I think that particular problem is already taken care of. So let's move on to the next question, which is question 2. Question 2. So question 2 now is about locating the point. Now, I mean, it's about plotting the point on the Cartesian plane. You can see question 1 is more about stating the coordinates, right? And question 2 is about now plotting the point on the Cartesian plane. So for us to do question 2, first thing, we need to draw a Cartesian plane, like a graph, okay? We need to first of all, put up our graph. Yes, you have the vertical line, which is the y-axis, and you have the horizontal line, which is the x-axis, right? So that's the very first thing you want to do to solve question 2. And this point where these two lines intersect is called the origin, just like Mr. Chinonso have explained to us. And right on top of it, on the y-axis, these are the positive values for y. You can just name them 1, 2, 3, 4, and so on. Remember, there are some times where you have to change the way you calibrate it. It might be 2, 4, 6, 8, 10. So it's all about scaling, yeah, to meet with what you're designing. So for this problem, let's just use simple number. Let's use 1, 2, 3, 4, 5. Yeah. So by the right, you have the positive values for x, and that's going to be 1, 2, 3, 4, and so on. And to the left of it is the negative values of x, and like that. By now, I'm sure every one of you here understand what is really happening here. That's the idea. You understand it. You can continue from this point. So the scaling of this graph is not a problem. Now we have this thing done. The next thing we want to do is to start plotting these points on this plane. Now, if you look at question 2, we have point L. This is point L, and it has the coordinate minus 5,5. Now, the first value in that coordinate is the x value, and the second one is the y value. So if you want to sketch this point on this plane, you want to find where x is minus 5 and where y is 5. So let's go on. Oh, I think I need to extend the x axis to the left. So I have minus 4 and minus 5. So we are looking at the point where x is minus 5, and this is the point where x is minus 5, right about here. And at the point where y is 5, that will be, just like you're standing on minus 5 and you move 5 units to the top. So that is somewhere around here, because that's the point where we have x to be minus 5 and y is 5. So you want to write L minus 5, comma 5. So that's pretty much how to sketch points on the Cartesian plane. A quick recap: you start with the x value, okay? X is minus 5. You come on the point where x is minus 5, and you're either going to be moving up or down, depending on the value of y. So because y is 5 and 5 is positive, we move up 5 units to the top, and we just mark that point where y is positive. So if y was negative, you're moving down, and you mark the point where y is negative. So thank you very much, Mr. Chinonso. Over to you.
All right, yeah, thank you so much, Mr. Michael, for that very clear explanation. So I think I will take one more point. So let's take point G. So this is point G, and it has a coordinate of 4 and -2. So what this means, the interpretation is we want to look for an x coordinate of 4 and a y coordinate of -2. So I want to come on the x-axis, I want to locate 4, which is this. And then also look for on the y-axis -2, which is this point. So I want to use dotted lines. And once I take dotted lines, a vertical dotted line and then a horizontal dotted line. So where they meet, so this is point G. And so I can also rewrite, so to say 4, -2. So what our students should remember is that coordinates are reported in the order x, y. So your x coordinate comes first, and then your y coordinate comes second. And then you can always use the Cartesian plane, the xy plane, and pick the points and then graph accordingly. All right, thank you so much, Mr. Michael. So this is point G.
Yeah, I really like the way you explain how to sketch the point G on this plane. I really like it. Just put the horizontal line and the vertical line, the point where they intersect is G. I mean, that's really straightforward. I mean, every one of you here can do that stuff. All right, so let's move on to the next question. That will be question 3. So in question 3, we are going to be learning how to sketch this graph, the graph of a straight line. That's what we're going to be doing in question 3. So just give me 1 second. So we have question 3, and question 3 is about sketching or graphing the line on the Cartesian plane. Every time you see a line, before we even start graphing lines on the Cartesian plane, I think I need to make you understand what lines is before we start going to graphing, because we have different kinds of lines. We have straight lines and we have wavy lines. You know, when you go to the beach, you see how these waters are moving. We call it wavy lines, right? We have zigzag lines. I mean, they are all lines, right? Different kinds of lines. We have, so many lines, right, Mr. Chino? So I think the only
we also have, exactly, we also have a parabola, yeah, which is the quadratic, yeah.
Yeah, so we have lines, right? We have different kinds of lines. But now our interest in this particular section is straight lines. It doesn't matter if the line is going down or, when you say straight line, most of them get confused about it. They feel like straight line must be vertical like this. No. This is straight line. Even if it's going like this, they are all straight lines. They are all straight lines, okay? So we're going to learn how to graph straight lines on the Cartesian plane. And I think what I'm going to be using here is the rise over the run. I mean, that is the idea I'm going to be using in graphing straight lines equation on the Cartesian plane. So just give me 1 second. Let me clear up everything we have here. Now, for us to graph any of these lines, these are all straight lines. And again, every straight line has a model. It's always going to be written in this form, y equal to mx plus c. I mean, different books may have different ways of expressing straight line, but that's not the problem. The problem is understanding what those variables interpret. Now, in this case, if your book is using y equal to mx plus c, that means the m here represents the slope. And another word for slope is gradient. Maybe you don't like the word slope. I'm sure gradient will fit in. Then that is the m. The m is the coefficient of x, and that is the slope or the gradient. And the c here is the y-intercept. Take note, the y-intercept. I might have to do a rundown on this and maybe do one problem, so we walk us through other problems. Yeah, so this is the slope or the gradient, and c is the y-intercept, right? So if you have this equation in this form, c plus ms, you shouldn't have a problem with this because, like I said, the x here, I mean, the coefficient of x is the slope, and the constant term, which is c, is the y-intercept. So however you may have it come to you, all you just need to do is to just refine it and get the slope and the y-intercept. All right, that is taken care of. Now, the next thing we want to talk about, like I said, the c is the y-intercept. When you have, let me quickly tell us what the y-intercept is. On the Cartesian plane, we just have two intercepts on the Cartesian plane. You can also call it the y and the x and the y plane. We have two intercepts. And the two intercepts we have is the x-intercept and the y-intercept. Now, what is even the x-intercept and the y-intercept? Let's assume we have this line on the red. Let's call it line L. You can see now line L cuts the y-axis. That point where line L cuts the y-axis is called the y-intercept. Okay? Sorry, my spelling. And the point where the line cuts the x-axis is called the x-intercept. And like we already discussed earlier, how to locate points on the Cartesian plane. Now, if you are dealing with the y-intercept and the x-intercept, they have coordinates, and those coordinates, they have coordinates, which is the x and the y values, right? Now, this is the origin. Now, if we say here is point A, and let's say we call here point B, for us to get the coordinates of the y-intercept with these values, that's going to be 0, A, because if you trace this point, the y-intercept, if you trace to the x-axis, you get 0, and already on the y-axis, which is right where it's actually at the point y-axis, it is point A, so we have 0, A. Now, for you to get the coordinates of the x-intercept, that's going to be the x value at that coordinate is B, so that will be B, 0, because when you trace to the y-axis, you get 0. So this is unique. What this is telling us is on the y-intercept, the value of x is 0, and on the y-intercept, on the y-intercept, the value of x is 0, while on the x-intercept, the value of y is 0. This concept is very, very important in solving problems in the future. So that is that for that particular case. The next thing we want to do now is to just pick a problem and solve. I'm not going to discuss all of the principles here. I think Mr. Chinoso will have some of them to share with you. So let me do question 3. That is this one, right? So that's the first question in this section. So the first thing I want to do is to put my Cartesian plane, just sketch the Cartesian plane. We'll do that real fast. This is the y-axis and this is the x-axis. This is 0. Let me just put in some values. This is 1, 2, 3, 4, and so on. We have 1, 2, 3, 4 like that. We have -1, -2. Let me take this up to -3. And below it, we have the negative values for x. We have -1, -2, and so on. So we want to sketch this one. We want to sketch question 3, which is y equal to -1 over 4x minus 3. Now, what do you observe? This is the same as the equation I gave you earlier, which is mx plus c. So you can see the slope is just -1 over 4. And the y-intercept is, going to be -3. Okay? That's the y-intercept, -3. So with that concept, what we just need to do, we start with the y-intercept, that point where the line causes the y-axis, and that is -3. So we start from here. Let me use a different color now. We start from here. We have the black, okay? So this is the y-intercept, right? So we have 1 point. And I think one thing I need to emphasize before we even draw the graph is 2 points is enough to draw a straight line. 2 points, when you connect 2 points, is enough to draw a straight line. So I just need another point to draw this straight line. Okay, now I have 1 point, which is the y-intercept, and that is on -3. Now let us get the other point to connect with the y-intercept. Now we work with the slope, the rise over the run, okay? That's the next thing we want to do. So at this slope here, we want to move this is the slope here is the same as the rise over the run, okay? So we want to move 1 unit up and 4 units right? So that's what we want to move. So that's going to be like we move 1 unit, which is the rise, and we now move 4 units to the right, and that would be sorry, let me withdraw this stuff again. So we move 1 unit like this, and next thing we move 4 units, we run 4 units, so that will be like 1, 2, 3, 4. Okay, so that is going to be the run. So when you connect these two lines together, you have the slope, the line, y equal to -1/4 - 3. So I just have to connect these two lines together like this. Yeah, I think that's how I need to do it. So that is the point. That's the line y equal to -1/4x - 3. The rise over the run. Yeah.
Just to draw your attention, I know you missed the negative sign on the slope. But, so I think we may need to move to the left now, just because the slope is negative.
Yeah, the slope is negative. Yeah, so that is the rise and the run. So we move to the negative direction. So that means we're going to add another point here. That's -4.
Perfect.
And that is going to be -1, 2, 3. I think I missed the line. Let me clean up this stuff and continue from here. So we have this one moving in this direction. We have 1, 2, 3, and 4. So we connect these two lines, and once we connect these two lines, that is the line y equal to connect these two lines from here. Yeah, so that is the line y equals to -1/4x - 3. Okay, that is that for this particular question. Just before I move on to Mr. Chinonso, you can also use the x-axis and the y-axis to also sketch those points, get the x coordinates, get the x-intercept and the y-intercept, and that will help us sketch this point. Okay, over to you, Mr. Chinonso.
Yeah, thank you so much, Mr. Michael. So I'll just work on question 4 here. So let's see if we can clear the screen.
Yeah.
Okay, so for question 4, again, I will just draw the XY plane. And then this is our y-axis, this is our x-axis. And then so I want to have numbers 1, 2, 3, and possibly 4. The same here, 1, 2, 3, and 4. I can also go ahead to have negative numbers, -1, -2, -3, and also on the y-axis, -1, -2, and so on and so forth. So to solve these, and remember, Mr. Michael has explained to us what all of these terms represent. So all of these show a model, and then the general linear equation is given by y is equal to mx plus b or c, as it were, where c is our y-intercept. And so the y-intercept is we're determining where the line would cross the y-axis. And, Mr. Michael also explained that at the y-intercept, x is equal to 0, and also at the x-intercept, y is equal to 0. So given this equation, y is equal to x minus 1, we can tell, looking at the coefficient of the x, the coefficient of x is our slope. So we can determine if it's going to be a positive slope or a negative slope by looking at the coefficient of x. So if the coefficient of x is positive, then our slope would look like this. Then if the coefficient of x is negative, then our slope will look like this. So we need to take note. So sometimes we have questions on the math section of any exam where sometimes you don't need to solve. You just need to look at the coefficient of the x, and that helps you know the direction of your straight line. So given this, we know that our slope is 1. So it's a positive 1. And I want to just quickly explain what a slope means. So the slope is the rate of change. It is equals to change in y all over change in x. So what this means is that, for example, if you get a slope as being equal to 2, what that means is that for every unit increase of x for every unit increase of x, y will increase by 2. So what that means, for example, we have values of x and y. If the slope is 2, what that means is, for example, you have 1, 2, 3, 4 on the x-axis. So it therefore means that on the y-axis would have, say, if we had maybe 2 here, for every unit increase of x, y will increase by 2. So to get the next value of y, I will just add 2, which is the slope. So that will be 4, and then add the next slope to get the next term, which is 6. Add the slope to get the next term, which is 8. So what slope helps us understand is, it helps us understand how the rate at which y is increasing for every unit increase of the x value. So in this case, we have our slope as 1. So what that means is, for every increase of x by 1, y also increases by 1. If the slope were 2, for every unit increase of x, so if x is, for example, at this point at here, if the slope is 2, it will mean that when it is at 2, I'm going to add 2 to get the next point at 3. So that's just an understanding of what slope means. So let's go ahead to solve, to graph what we have here in question 4. So it is given that the slope is 1, so I can always tell. And then the y-intercept is -1, so that is this point. And then since my slope is positive, I expect my line to go in this direction. And so the next thing I want to do is, I want to just get a point, because I know that for every unit increase of x, y increase by 1. So I can get my second point as, take the point, say, we already have a point. And then I want to also use what Mr. Michael explained. So we want to also get the y-intercept and then the x-intercept, for example. So I can say, I want to get the x-intercept. So at the x-intercept, y is 0. So this is the equation we know. Y is equal to x minus 1. So at the x-intercept, y is 0. So I want to get what the x-intercept will be. So that will be 0 is equal to x minus 1. And therefore it will mean that x is going to be equal to 1. So I can now pick another point, which is this. And then once I connect this line, these 2 points, I get the graph of these. And then if you want to also confirm that, you can go ahead to find the slope, which now you pick a point. Well, this is not a perfect graphing stuff, so you not get the coordinates, but if you use a graph paper, you can always get this correctly. So this is the basic rule of graphing a linear equation. Yeah, so thank you so much. Please, if you do have a question, feel free to drop it in the comment section. We'll be more than happy to respond to you. And also look at the description of this video, visit our website, and book some of our lessons. We are always there to guide you through math concepts. It will be from counting to calculus. Thank you so much.
Yeah, thank you very much, Mr. Chino. So that was clear. And thank you for helping me figure out the negative sign I missed out. Thank you. Thank you for that one. Yeah, I think by now we are good to go when it comes to graphing straight lines on the Cartesian plane. There are so many ways you can do it. You can use the table system, which Mr. Chino also showed us here. You can put the x value, and then you put the y value. The x is always the domain, y is the range. So when you put the values of x and you put the value of y, then you can now connect any 2 points, right? And once you have, like I said, 2 points enough to graph a straight line, just 2 points enough. So once you have your x value, just put in any random points, 1 and 2, or 0 and some other number, you have the y value, sketch the point. Another way is to use the rise and the run, which I used earlier. And Mr. Chino also showed us how to use the x-intercept and the y-intercept. So you can see you have the x-intercept, you have the y-intercept, you connect the 2 lines, and you're good to graphing the straight line on the Cartesian plane. So if you're watching on YouTube, you're welcome, and subscribe to this channel for more videos like this. And I think we are fine. Mr. Chino, so what's the next thing we are doing?
Yeah. Well, I just think we can take a few more. I think I can take just maybe one or two more questions just to explain some other questions that are nuanced here. So if you don't
Okay,
mind, I
please.
would love to take two more.
Yes, sir. Please go ahead.
All right, yeah, thank you so much, Mr. Michael. So this time I want to look at question 12 because it's a little bit nuanced and some students may get confused and say, oh, come on, there's no y-intercept here, so how can I go about that? And then I'm also going to look at question 15, which is not readily expressed in the y-intercept form where we need to rearrange. So looking at question 12, this is y is equal to 1 over 2x. And so some students may say they can't find the y-intercept. So in the event that you have such an equation, students, I want you to know that the y-intercept here is 0. So there's an invisible 0 there, and we do not need to write that, but there's a 0. So again, we just have to use the same principle as we had. We want to have our xy plane, and then this is our y-axis, and here is our x-axis, and then we can label the graph. So this is 2, 3, 4, and so on and so forth. 1, 2, 3, and 4. I don't think I need a negative coordinate here because everything is positive. So again, the slope here is half. And so what that means is for every increase of the x value by 1, the y value increases by half. So if x increased by 2, y would have increased by just a unit, just so it could augment. And then looking at the sign is a positive slope. So by inspection, if, for example, a student had drawn something like this as his answer or her answer, I would definitely just know that it's wrong just by inspecting without having to consider the coordinates to know if the slope would be equal to just half. So to solve this, I definitely know that my slope must go upward, forward. And then the slope must begin at the origin because the y-intercept is 0. So when you do not have a constant term, I want you to know, my dear students, that the y-intercept is 0. So that means the line will definitely cut the y-axis at point 0, which is the origin. And then, so you want to get another point. And just like I've said, we want to have, so this, you can also take the slope as a coordinate. So you can have 1 and 2. This is also perfect. So in the event that you have, say, for example, in the first equation, that would just be 1 and 4. But then it's going to be in the opposite direction. So in other words, you're going to take it on the other side. So this is going to be, for example, you would have had a negative 4. So this is it's very good that students understand it. So in terms of building on fluency, that's when we tend to emphasize all of those explanations. So given that, we can now go on to say that I think I've interchanged this. This is not how it's supposed to appear. Because this is half, not 2. This, what I've given is when it is 2, so it's half. So 2x is going to be 2, while y is going to be half. That the reason is, remember that slope, which is m, is equal to change in y all over change in x. So for it to result to half, it therefore means that your x is greater. Good. So in other words, so this is my x and then this is my y. So I want to pick the point, this is the point on the x-axis and then this is the point on the y-axis, and I want to use my dotted lines and get where they intersect. So this is that point. So once I connect these two points, I get the line of the equation of the equation of question 12. I want to trust that our students are understanding this. Again, if you have questions or you need further clarification, please feel free to book a consultation with us. Feel free to book for our classes. Our classes run, and then we'll match you at your proficiency level. We have an assessment test where we use to diagnose and assess you at the level you are at math. At our academy, we emphasize mastery-based knowledge. So we want to make sure that all gaps are filled. So we'll test you and give you contents that match your exact and present mathematical level. All right, so I'll just move to the next question I highlighted, which is question 15. So again, students may get, this question may confound students because it is not reported readily in the in the slope-intercept form. So this is question 15, and I'll write it here. So that's 4x plus y is equal to 5. So this is not readily in the xy or in the slope-intercept form. The slope-intercept form of a linear equation is represented by y is equal to mx plus b. So when you are given this kind of equation, you want to rearrange the equation to conform to this general equation, and that in that way. So for example, a student may erroneously say that the slope to this equation is 4, but that's not true because it is not represented in this slope-intercept form. So we want to make sure it appears just like this, where y alone stands on the left-hand side. So to do that, what we want to do to the equation of 15 is to subtract 4x from both sides. So in subtracting 4x from both sides, so I'll just quickly clean these off here. Okay, so to make it look in the y-intercept form, I want to subtract 4x from both sides of the equation. So the left-hand side and the right-hand side. So of course, this cancels this out. So I'm left with y is equal to negative 4x plus 5. So the slope to this equation is negative 4. And that now helps me know the direction that my line should go. So it's going to be something like this. So on the XY plane. So you want to draw the XY plane and get coordinates. So this is our Y coordinate, our X coordinate. So we want to have a 1, 2, 3, 4, and possibly 5. And then the same on the X axis, 1, 2, 3, 4, and 5. Let me just have a few negative coordinates here, negative points, negative 2, negative 1, negative 2. Okay, so we want to go ahead to plug these. So looking at these, our y-intercept is 5. So we trust and we believe that it's going to cut the y-axis at this point, which is the 5. So the y-intercept is where the line cuts or intersects the y-axis. So it's going to be at 5. And then the slope, negative 4. What negative 4 means is for every unit increase of x by 1, y decreases by 4 units. So what that means is, say, for example, we have a point. Let's use tables here. Let's use tables just to further explain it. We have x and y's. So we have, say, 1, 2, 3, 4. If y, for example, began at say 8, what we are saying is when x increases to 2, what should happen to y is that it should drop by 4. So that's, we're going to have the next value of y will be 4. The next value again, that's for 3, will be 0. And then the next value will be negative 4. So I want you to know this, that the slope gives you an idea of how y increases for every single increase of x. So if x increased by 1 and y increased by 2, your slope is 2. If x increased by 1 and y reduced by 2, your slope is negative 2. And then, so that's just on the other side, on a lighter note, and then to help you understand how to get the slope and what the slope means. Then we can also, for precision, also use the x-intercept. And at the x-intercept, our y is 0. So we want to get that too. So let me just use that, because we want to ensure that everything we do is precise and very accurate. Okay, so having to do that, so I want to plug in, so I want to get the value of the x-intercept. I will say that the x-intercept y is 0. So that's 0 equal to negative 4x plus 5. And then to go on to solve this, I want to add 4x to both sides. So that's going to be 4x is equal to 5. And then to get the value of x, that will be x is equal to 5 divided by 4. So now I have gotten something. And then again, what you want to also do here is you want to take the opposite of, so since the slope is negative 4, this is m is negative 4. So what that tells me is that for example, when I had 0, so it's going to be 0, comma, -4. So I don't have -4 here. Let's say we have -3 and -4. Okay, so again, we can then go on to plot this graph. Let's get the point. So we have -4, which is somewhere here, and then well, this has to be somewhere around negative. So -4. Let's count. This is -3, -4, somewhere here. So our slope, our line now is a little bit dicey here because of the numbers and probably how I've drawn this graph. Okay. Maybe I need to draw it up because the points may not even enter.
Yeah, one
That's one thing with
question.
math sometimes.
Yeah, sorry
Yeah.
to interrupt. I think so what I think from some of the graphs in general, I'm guessing that using the y-intercept point, locating that and then using the slope to go up and down, right? So I wanted to double check
Mhm.
from the one you're looking at. Which number was that one again if we need a new sport?
That was question I think we're working on question 15.
Okay. So this one, okay. So in that case, so they would have so I think I apologize. I know we had a lot of writing on our screen, but I think what you meant there was to find their y-intercept there, which was 5. And of course, again, there was a lot of writing there. So I'm guessing so you have your I think the 5, right? And then I think you were using the -4. So maybe then that comes down on that one. So I think that sorry to interrupt, but I think that with all the writing on the screen, we might have mixed up our slope and y-intercept. So the y-intercept for this
Yeah.
one was -4x plus 5. So then we go to plus 5. Now, the interesting thing is growing up in Nigeria, we actually didn't use this method as much. We used to use the table of values for everything. But I found out that in America, people don't always. The funny thing about America sometimes is they're not looking for what makes you sweat the most. They're looking for what's the most efficient. And so the most efficient would then be I go down for 1, 2, 3, 4, and then 1 over, right? So they'll draw they'll find the 2 points and then connect them. So I think for that one, so again, I think that's just we'll get our whiteboard maybe cleaner in the future one. But I
Yeah.
apologize to interrupt. I do have to apologize for interrupting you, but I wanted to just catch that in case the guests were looking for the y-intercept first. So that would be 5 because y is equal to -4x plus 5. And the format, as Mr. Chinonso said, is y is equal to mx plus b. So the slope is -4/1, essentially. And therefore, we go down 4 and over 1, down 4 and over 1. So you're going to have a negative slope. The negative slope is key. So let me just mention one more thing and then over to you again, sir. And that is that we basically have when the slope is negative, our graph will go like that. And when the slope is positive, our graph will go like that, right? So hopefully our students and our parents are paying attention to that key element. So over to you, sir. Thank you again for your work. I'll let you guys carry on.
Yeah, thank you so much. Yeah, just like you mentioned, we had a lot of writings on the board, and that could be confusing, but you've put it clearly. So the slope, we already had the y-intercept as 5, which we pointed, and then the slope -4/1, which gives us the coordinates where -4 for y, which essentially is what you've given us. Yeah, thank you so much. So I think we've exhausted the questions we've said to exhaust here. So Mr. Michael, maybe we can go on to the next section.
Yeah, thank you very much, Mr. Chino. So thank you. Okay, yeah, thank you very much, Mr. Chino. So I think earlier it's just because we have a lot of writings on the screen, and that alone could bring some kind of little uh, oversight of some things, the negative and the positive, and we just pick them like that. So, but it's clear now. I think every student now know how to draw that graph. But while you were solving question 12, something just came up to my mind, and I would like to share. I mean, I think that would be very important, because some of the times, like question 12 is quite different from every other questions, right? Sometimes we can have questions like this. We can have y equal to 3, and they want you to graph this line. I mean, like we said, we want to graph this line, y equal to 3. And this can be a lot confusing for some students. They'll be like, oh, this is not the graph we know. It should be in this form, y equal to mx plus c, right? But now, if you must model this y equal to 3 in this form, that's going to be y equal to 0x plus 3, right? Just like Mr. Chinonso have explained. Those ones that are missing, you can also use 0 to just complete it, and it still works. So I'm going to show you how to do this stuff now, and we'll move on to the next section. Now, if you want to graph this line y equal to 3, how do you graph this line? If you graph y equal to 3, I also ask you to graph x equal to 3, maybe as your homework. So the first thing you want to do, you want to draw the vertical lines, and you want to draw the horizontal lines, so that you have x, y to the y as the vertical line, y axis on the vertical line, and the x axis on the horizontal line, and the point where they intersect is the origin of this Cartesian plane. Now it is very clear that the y-intercept here is 3, right? It's very clear, it's 3. So if we calibrate this y-axis, so you have 1, 2, 3, 4, and so on. But we just need 3, so let's just stop at 5. Then on the x-axis, we can just put in some numbers. We have 1, 2, 3, and let's just put in some negative numbers, and like that. So this is pretty much what a Cartesian plane looks like. Now, the first thing we know here, we know the y-intercept, which is 3. So let me use a different color. Let me use red, dark red. So you want to mark this point where y is equal to 3. And if you're using the rise over the run as the slope, the rise over the run. So the 0 here is the slope. So you can rewrite that as 0 over y. So that means you're not changing. Moving up, there's no change moving up. So the 0 there tells you that there's no change moving up, because 0 means nothing, no change moving up. So, and you want to now move 1 unit to the right. So that will become no change moving up. So you want to keep moving like this, and like this, and like this every time you get a point. Okay, so that is going to be a straight line when you connect them together. So that is the line y equal to 3. And another way you can think of this is, you can see at every value of x, y is going to be 3. At every value of x, y is always going to be 3. So this is how to draw it. So if I come over here and I draw this line like this, you can see this line will be y equal to 5, because for every value of x, y will always be 5. And the same thing, if you want to draw, maybe if you want to sketch x equal to -1, so you want to just come on that point where x is -1, and you draw that line that passes through that point, -1. So this is the line x equal to -1. I hope that makes sense. So you can just add that to one of the things you've learned today on how to graph straight lines on the Cartesian plane. So thank you very much, Mr. Chinonso. Thank you for walking us through how to graph straight lines equation using different methods. So I think by now our students are looking very good on graphing straight line equation. Let us move on to the next section. Or Mr. Chinonso, what's the next thing we want to do from here?
Yeah, I think we can move to the next section, but probably we can let them take note of two important scenarios where we have slopes. For example, if this is our XY plane, so this is our y-axis, and then this is our x-axis, it is possible to have a line that is just vertical, perfectly vertical. So the slope of this line is going to be undefined, and that is because for example, if you have 2 points, you will notice that the x-axis is not changing, so it remains at a fixed point, whereas the y-coordinate is changing. So let's say, for example, this is at 1, and then this is at 2. So if we want to get the slope m, which is change in y all over change in x, is going to be, now we know that our change in y is going to be 2 minus 1, which is equal to 1 essentially. And then our change in x is going to be, at this point, say is 2, which is 2 minus 2. which is equal to 0. So so 1 divided by 0 is undefined. So a line that is vertical or parallel to the y-axis has a slope that is undefined. And we could also have another scenario where the line is parallel to the x-axis. So at this point, the slope is 0. Yeah, so this is just one, these are just two scenarios that we can also point to students because sometimes in some exams, this may just come up. Yeah, so thank you so much, Mr. Michael. Over to you. I think we can move to the next concept.
Thank you very much, Mr. Chino. So that is very important. We need to know the slope for different cases of the line we are sketching. Mr. Chino also have made that clear to us. We can have the slope to be negative, and you know how the line should be. And when the slope is negative, you know how the line should be. When the slope is 0, I mean, there's no slope. That is when you say the slope is 0. You know how the line should be. And when the slope is undefined, you should also know how it should be. So these are the 4 cases for different kinds of slope in graphing a straight line. So right about now, I think we move on to the next section. For those of you who are just joining the live stream, this is the Council Calculus Squad, and we do this same time every day. All you need to do is just to subscribe to the channel. Make sure you put on your notification bell so that whenever we go live like this, you'll be the very first person to be notified on the channel. And if you love what we are doing, kindly share this link to your friends, to other group of learners you have on different social medias. And that's one way to appreciate us, and we'll be grateful for that. So right about now, we'll move on to the next section. Oh, this is just the, Mr. Chen, this is the last question. This is the last question in this section, graphing or sketching straight lines. This is the last question here. So the next one here is about slope. I think that is what you're even talking about. It's about slope. That's the next question, is about slope. So let's quickly just move on to the practice problem side. And then we'll start solving problems. Start talking about the slopes and the other stuff that comes with it. So 1 second, guys, 1 second. Yeah, so Mr. Chino, so I'll leave this one for you. Maybe you can go ahead and explain different cases of slope here, and maybe somehow we can also find some questions. And I also like you to give them some questions to do. So those of us who are joining on YouTube, you can give them some questions to do, and once they have the answer, they put on the chat box. Okay, yeah. So over to you, Mr. Chimonso.
All right, yeah, thank you so much, Mr. Michael. So this is a very important type of question where you provided with a graph, and all you need to do is to find the slope to the graph. So very easy to solve. You don't have to stress yourself. So all you need to do is, you remember this formula for slope, which is m is equal to your change in y all over change in x, which is equal to, say, y2 minus y1 all over x2 minus x1. So you want to get 2 points. So we could say, for example, in question 1, we could label this first point as point A and then this as point B. So what we want to do is we want to get the coordinates of both point A and point B. So looking at point A, what's the coordinates? Remember, in previous section, we've been able to identify how to get the coordinates of any point. So looking at these, it corresponds to this point at the y-axis and this point on the x-axis. So the x coordinate here is -1. So point A has -1, comma, and then the y-axis, on the y-axis we have is 1, 2, 3, 4. So the coordinate of point A is -1, 4. So we want to get the coordinate of point B. You remember Mr. Michael had told us that in getting the slope, all you need, you just need 2 points. Once you have the coordinate of 2 points, you are ready to get the slope. So we want to get the coordinate of point B, and on the x-axis, it's this point. So that's -1, 2, 3, 4, 5. So we have a -5, comma, and then on the y-axis, we have it correlates to this point. So that's -1, -2. So having done that, we are ready to get the slope of the first question. So that would be, remember this equation, y2 minus, so to make it a lot easier for you, I would use YB, XB, and then YA here, and then XA, just so you can fully understand. I could also label these points at point 1 and point 2, yeah, just for conformity. Okay, so to get these, what's my YB? My YB, this is the coordinate of Y in point B. So that's -2. Then I have my minus YA, and this is A. This is the Y value of point A, which is 4. And then I have that all over. Now, what is my XB? So that's the X coordinate of point B, which is -5. And then I have my minus, which is inherent in the equation. And then XA. So what is the X coordinate of point A? It is -1. So I have a -1 here. So then I can go on to solve for the numerator. That's -2 minus 4, which is -6 all over. So I have a -5, and then if I distribute this negative across, so I'm going to get positive. So that will be -5 plus 1, which is equal to 6 all over 4. So I can go on to simplify to get 3 over 2. So the slope to question 1 is, remember, this is -6, which we have, and then this is also -4. So that's why I just had 6 over 4, but I'm just trying to let our students know. So that becomes 3 over 2. And then you can also look at the nature. See, the graph is going upward, forward, confirming that it is a positive slope. So if it were a graph that looks in the other direction like this, it's going to give us a negative value. All right, I believe that makes sense. So we can do the same thing for the other question. So let's take for question 2, for example. Mr. Michael, all right.
Sorry, I just want to add a little to what you've said about solving, finding the slope for question 1. You can also use the rise over the run, like we already discussed. Slope is the same as the rise upon the run to get the slope. I mean, that's still another way to finding the slope of a line. So if you do that, if you start at point B and you're moving, let's say we'll move 1, 2, 3, 4, 5, 6. You can see we are just at the point where we have the A, right? So that is the change. The rise here is 6, so we have 6 right over there. And if we move to the point where we have the A, so you have 1, you have 2, you have 3, and you have 4. So that would be 6 over 4. And when you reduce this to its lowest term, that's the same as 3 over 2. So you can still use this method to finding the slope of the line. Now, this method, using the change in y upon the change in x is very important when you're solving some SAT problems, where you need to find some variables that contribute to the change. So you also need to understand this method. So it is very good as math students. It is ideal that you don't just learn how to solve a problem just one way. You can learn how to solve a problem various ways, and that's going to help you a lot. I mean, those methods are very important in some certain way. I mean, every math question wants you to think in a certain way. So every problem we are solving here with different techniques or different ways would want you to think in a different way. So that is that in solving question 1. Thank you, Mr. Chinonso.
And if I can jump
Yeah,
in.
thank you.
Thank you,
Right.
So again, Mr. Michael, I want to jump in and just mention 2 things quickly, family. So the first thing is, when you solve equations and all these things we're talking about, it's also good to understand the context, the historical context, and the application. So let me give you guys 2 quick applications. For equations, which we discussed earlier on, a lot of algebra actually stems from the Middle East in terms of how it was formalized. So the number system we use in pre-algebra and all these numbers you hear, they call them the Hindu-Arabic system, because there is this story of taking the work in India, bringing it to the Middle East, and then Leonardo of Pisa bringing that to Europe. And there's a whole story about that, right? So it's important to understand the history. Why do we do what we do in maths? Where did it come from? The other thing about the history we're talking about here is the graphing you're talking about with coordinate geometry is traced back to a man called René Descartes from France. René Descartes was born in 1596. He lived till about 1650. And he laid the groundwork that affected Isaac Newton, people like Leonard Euler, Albert Einstein, but it goes back to René Descartes. So students, look up René Descartes and try and learn the impact that he had on mathematics. Lastly, let's talk about the applications. Students, you've probably seen something called the speed limit. When your parents are driving and it says 25 miles per hour, do you know that that is a slope problem? Like that's dealing with the slope. 25 miles per hour. And so if you were to graph it, this would be the miles, the distance on the left side, and this would be the time. So when we're talking about slope, it also is dealing with essentially this idea of speed limits, right? And Isaac Newton played a huge role in discovering the work that, you know, with lines and derivatives and stuff like that, right? So Isaac Newton did his work in the 1600s. He lived from 1642 to 1727. So Isaac Newton's work is part of what leads us to this discussion of calculus. So let me just mention one more thing and I'll hand it back to the team. Do you know one of the interesting things about mathematics is that we tell kids to learn algebra, but they don't need to learn calculus. That is one of the worst ideas in history. Why? Because why would you tell someone to learn something that is going to lead to a story and then remove the story? That makes no sense, right? So the math education system makes no sense in many places. And I know Mr. Amos is coming off a little intense on this. And the reason is this: if you're watching this live stream, or any of our students or anybody who's trying to learn math, you can do math. You can do a lot of math. Don't let anyone tell you you can't. And don't listen to anyone who's limiting you. You should do math daily, literally till further notice. Keep learning, keep growing, keep flourishing. Don't stop and don't allow anybody put a limit on your math learning. Math is like gold. The people that know math in this day and age will have the greatest opportunities in STEM fields, in quantum computing and AI research. Whatever you want to do, if you know math, you will go far. So if any society limits your math, go beyond what they're teaching. Go way beyond it. And that leaves me with one more story for you guys. This same Isaac Newton, who went to Cambridge University, another guy went to Cambridge University, and the guy read this book. His name was Srinivasa Ramanujan. And what you will learn about this guy, he was a self-taught mathematician. You can learn a lot of math. And so some boys, especially, I mean, some students, maybe you're playing games and you're just hanging out and you don't have a vision for your life. You need to become good at math, like really good. And how do you know you've got good enough in math? I think I have a litmus test. Let me tell you my litmus test. Your school should say these words to you: we don't know what to do with you anymore. You don't fit into our standards. You've gone way past what we're doing. That's when you know, perfect, I'm good to go. Because the resources available now, you can go to the moon in mathematics. Like, you can go far. And so don't, like, every day, make it a habit. Grab a notebook, a place to write. Every day, grab something to write with. Open it up, write the date. On Wednesday, Mr. Michael and I and Mr. Chino, so we're going to talk about how to take notes. Like, we're going to dive deep into that as a separate session. And we want every student to have a notebook, take good notes, and then watch what happens. Math is beautiful. Let's keep working hard. So keep up the good work. Just wanted to say hello. And thank you to those who joined. I see one of my friends from Georgia. He knows himself. Thank you so much for stopping by and enjoying some of our chats. But I look forward to chatting with you after too. So over to you guys to take us to the finish line, maybe in about 20 minutes, if it's okay.
All right. Thank you so much. Okay. And then, thank you so much, Amos, Mr. Amos, for coming up with that. The idea is that mathematics has a lot of practical, so it's practically, and we can apply it in our everyday life. And that's a topic or a concept in maths known as mathematical modeling. So you might ask yourself, so why do I have to learn, or why do I need to learn how to graph or express a linear equation? So say, for example, we've been talking about the linear equation where we have y is equal to mx plus b. And you might be asking, so how does it apply to me? Why do I need to learn this? You can use it in mathematical modeling. For example, I'm going to give a practical example. Let's think of a boy named John, and we say John currently has 3 shoes. And after every month, he buys 2 new shoes. So I can mathematically represent that statement. And that's a topic known as mathematical modeling. So I said John currently has 2 shoes. So he has 2 shoes currently, and every month he buys 3 new shoes. So looking at these, I have a y-intercept, I have a slope. So I can represent it using the linear equation because the number of shoes he has increases at a constant rate. So, and then the shoes he currently has is the y-intercept. So in real application, the y-intercept, which is the slope, just gives us an idea of what you currently have or the initial of any variable. So we can model this situation where we say John currently has 2 shoes, and after every month he has 3 new shoes. So there's going to be y is equal to 3x plus 2. So with this mathematical model, I can know the number of shoes he's going to have in 2000 months by just plugging in. This is the input. So in the y-intercept, slope-intercept form, the x is the input and the y is the output. So it just gives us a function or a model that we can use to get values. So I can know the number of shoes he has in 2 months, in 3 months, 4 months, and so on and so forth. So for example, I want to get the number of shoes John is going to have by month 10. So that's going to be y is equal to, after every month, he gets 3 new shoes. So that's going to be 3 multiplied by the number of months here, which is 10, plus what he currently has, which is 2. So that's 30 plus 2. So we have 32. So by month 10, he's going to have 32 shoes. So this is just to further explain what Mr. Amos is talking about. So math is something we practice every day. It's not just abstract. All right, thank you so much. So Mr. Michael, I think we can move on, right?
Yeah, thank you for that one. So that is a typical SAT question. That's a typical SAT question. So for those of you who are preparing for the SAT or the ACT, that is a very typical SAT question. I mean, you're going to see a lot of problems in that regard. All right, I think we might just need to do one more question here, and let me see. Let's just do a few more, and let's see where it takes us to the next. So question 2, if you want to get the slope of this line, you can use the coordinate form, or you can also use the rise over the run. Okay, so if you may use the rise over the run, sorry, I think my pen, I need to connect my pen. Okay. So if you want to use the rise over the run, you want to start with this point here, and let's see how many units we rise to the point. Okay, let me just label the point so that we have a roadmap of how we are moving. So let's call this one here point A, and let's call this one here point B. So when I say move from A to B, you understand the roadmap, right? So if we want to see how many units we rise to this top where we have the point B, let's go. We have 1, we have 2, we have 3, we have 4, and we have 5. So that would be 5. Remember the slope. Most of the time we use M to represent the slope. So I may want to write slope right here. So that will be 5 upon now the run. So we just move 1 unit to the right, and that is 5 over 1, and that is the same as 5. So that is basically how to find the slope. You can also use the coordinate form. If you're using the coordinate for point A would be 1, 2, sorry, that would be 2 comma the x-axis and the y-axis. So that would be 2 comma, sorry, not 2, minus 2, right? So the A will be minus 2 because I'm actually in the other side of the x-axis. So that is the negative side, right? So that would be negative 2. And now the y-axis here would be 1, 2, 3. That would be negative comma negative 3. For the A, that's the coordinate of point A. Then the coordinate of point B, you can see that will be 1 on the x-axis, and that will be 2 on the y-axis. So that is it. So we have the coordinates for these two guys. You can also use the slope formula, which is the change in y over the change in x, and that is the same as y2 minus y1 upon x2 minus x1. You go ahead and put any of the points here. So this is your x1, y1, this is your x2, y2. So the change in the y, that will be like 2 minus minus 3. So that will be 2 minus minus 3. And the next will be change in x, which is 1 minus minus 2. Like that. So when you add up, when you have two signs right next to each other, side by side, you want to remember the principles of how you operate negative numbers. So negative, negative, or negative times negative will give us positive, right? And that is 2 plus 3. And over here in the denominator, we have 1 plus 2. So when you add up all of these numbers, you're going to be having, sorry, did I make any mistake? I think I'm seeing 5 over 3. Let's see. Let's see. We have 2 minus 3, and the x-axis. I mean the point A. We have 1, 2. That's -2, and we have 1, 2, 3, and that's -2, -3, right? And here we have 1, 2. So where did we miss any points? 1, 1, 2, 3, 4, 5. Where did we miss any point? So changing y, that's 2 minus 3, and 1 minus 2, and that's going to give us 5/3 as a slope. Is there any point where I missed it using the rise over the rod? Is there any point where I missed it? Let's see. 1, 2, 3, 4, 5, and 5/1. For the coordinate, are we good with the coordinate? Do we make any error writing the coordinates? I think the coordinates are good, right? We got the coordinates correctly.
Yeah.
Did we get the coordinates correctly?
Yeah, I think we actually got them correctly. So that's -2, -3, and then 1. No, this is -1.
Which
This
one?
is -1, right? The B, the x coordinate is -1, I think.
Oh, sorry. Thank you very much. So that is -1/2. Thank you. I think these stuff are really too small. They are really too small. So let's now complete the solution. So when we put the -1 right here, thank you, Mr. Chinonso. So we have -1 plus 2, and that will give us +1. So that will be 5/1, which is 5. So one thing about math is if you truly know what you're doing, that's going to help you to be more confident. Even if the answers are not corresponding, all you need to just go back and check what you're doing. And with little or no time, you'll find where you're missing it. Thank you for that one. The point where I got it wrong was where I was putting the coordinates for point B. I used 1, 2, which is supposed to be -1, 2, because actually I'm on the left-hand side of the x-axis. So that is the negative part of the x-axis. That should be -1, 2. And I was using 1, 2, which is the wrong. That's why I got the question wrong at the first try. So you see, you can either use the rise over the run, or you can use the coordinate form, and you're good. They all work out well and give us the same solution. Thank you very much, Mr. Chinonso. We still have, I think, let's see the other questions down the line. Let's see if we might need to solve some more questions. And then
particularly interested in question 3. Now, previously we spoke about 2 scenarios where we have the line being parallel to the x-axis, and when it's also parallel to the y-axis. So in this case, that's in question 3. This line is parallel to the y-axis, and therefore we do not necessarily need to compute the slope. We just know that it's undefined. The reason is, for example, you take your rise is 1, and then your run is 0 because nothing is changing. So that's 1 divided by 0. And then, of course, 1 divided by 0 is an undefined operation. So it's very important that students know that. So I wanted to just highlight that.
Yeah, that is true. That is true. I think Chinonso also said that earlier. When we have different categories of slope, this is one of those cases where you have your slope to be undefined. And the other case is when you have your slope to be 0. Let me see if we have that. Yeah, this is case question 10 point where your slope is 0. I mean, let's think of slope. I mean, when I teach slope to SAT students, that's how I always explain it. And I feel that way it makes a lot of sense. Let me just see if I can just use a minute or two to just share with us. If I'm going to draw the cases here, let's call this one case 1, okay, and let's call here case 2, and let's call this other one case 3, and we have the last one, case 4. Now, slope is this way. If I have this line going like this, you can see, like Mr. Chin also said, this is a positive slope. So of course, this line has slope. When you're walking along this line, imagine yourself to be this stick man. You're walking along this line. There's a slope here. I mean, this is not plane. So you experience a kind of force of gravity. If I will take it to the physics, you experience a kind of pull. You need to put in more energy to move up to the top. And if you're walking down this line, you're going to be, there's also another slope here. You kind of, if you're walking in this direction, also there's also a kind of free movement for you. So there's a slope. These lines are not plane. So this is negative slope and here is positive slope because we're moving positively to the first quadrant of this plane. Now for this other one, case 3, when you have this line like this is an horizontal line, right? And you're standing right here, you can see there's no slope here. This is the case where the slope of this line is 0. And here, you kind of fall in free fall. This is a free fall. So the slope here is undefined. You cannot measure the slope here. You cannot measure the slope here for this kind of case. I mean, you can even apply some kind of physical applications. Yeah, in this case, you cannot measure the slope at which this line is going down. All right, so that is just the 4 cases of slope you would want to see in any of the graphing questions you see in your textbook. So that is about that one. Mr. Chino, so I think we can now open the conversation. So those of you who are watching on the live stream on YouTube or on Facebook, or maybe you're actually on the call, you can go ahead and put in your comment. I mean, if you have questions on slope, if you have questions on one-step equations, if you have questions on two-step equations, if you have questions plotting the points on the Cartesian plane, or maybe locating the points or sketching the points or writing the coordinate of the points. I mean, any of these ones we've covered so far, kindly put it down on the comment section. I think this is the interactive point where we can relate to what you're saying. You've been all there listening, so I think we need to now talk to you, get to know what you're thinking, and let's see if it's something we can take right on this call. Like we also said, if you want to connect with any of the tutors one-on-one, you can reach out, you can check on the website on the description of this video, and that will lead you directly to our admin, and that admin is going to walk you through how to meet a tutor. So let me go check this chat. Mr. Chinon, so over to you.
All right. Thank you so much, Mr. Michael. It has been a wonderful one, and I trust that our audience are learning math. We had a webinar previously, and then we asked a very pertinent question where we asked if there are math people or people who were born with natural talent to excel in math. And one of the responses we got, which is the prevalent and which should be the answer, is there is nothing like anybody is a math person. Just anybody can learn math. Math is not restricted to a certain group of people who are said to be talented. We build our mastery, we gain knowledge by learning concepts, by learning math skills. And as we increase that, just anybody can learn math. So thank you so much, Mr. Michael. So I think we've pretty much answered these questions. I would also love to get responses from our audience. Please feel free to put questions in the comment section and then in the chat box, and then we'll be more than happy to respond. So we can always, just like Mr. Michael has said, we can get the slope by using rise over run. So M is equal to rise all over run. So for example, I want to get the slope of this graph. Now looking at this, I want to say, what is the rise? So the rise is just 1 here, so that's 1 all over the run. Now that's 1, 2. But in this case, it's to the negative direction, so it's moving to the left. So that is why the slope would therefore be, so on the denominator side, I'm going to put 2, but it's going to be a negative slope. This is because the run went to the left side. Yeah, I think that's pretty it. Well, I think we have a question in the Q&A section, and then it says, can you further explain the 4 cases of slope? So, Mr. Michael, would you want to talk further?
Okay, please go ahead, sir. Please go ahead. Go ahead, sir.
Yeah, so the question is, can you further explain the 4 cases of slope? Okay, let me just answer that quickly. Thank you so much for that wonderful question. And so the four cases are, of course, we have positive. So let me just clear the screen in a moment. Okay, so the first case is where you have a positive slope, which appears like this. And what that means is that for every unit increase of x by 1, the y will also increase. So depending on the slope, for example, if the slope is 2, so this is a positive slope, and then it's moving upward and forward. You can see it's moving upward, forward. So what this means is that for every unit increase in the x value, the y value will increase by 2. So for example, if you have values of x and y's, a table, so this is 1, 2, 3, possibly, and then your y begins maybe at 0.2. So for a slope of 2, what this means is that when x increased by 1, when you added 1 to x to get 2, y will increase by 2. So that becomes the next value for y when x is 2 would be 4. So I add 2 plus 2. And then the same thing, to get the next one, when x is 3, I'm going to add another 2 to give me 6. So this is the first case. The second case is when it is a negative slope. So in that case, your graph looks like this. And what this means is now for every increase of x by 1, y is going to reduce or decrease by a certain variable depending on the magnitude of the slope. Say, for example, the slope is -2. Now, what that means is that for every increase of x by 1, y will decrease by 2. Now, let's again use a table to demonstrate that. We have values of x and values of y's. And then we could have values of x, 1, 2, 3 again. And then on the y side of things, we could begin with, say, 12. So what this means is that as x increased by 1, our y value is expected to decrease or reduce by 2. So at x equal to 2, y will be 10. And at x equal to 3, we are going to also subtract another 2, which is going to be 8. So what the slope tells us is for every increase of x by just a unit, our y value will decrease by the magnitude of the slope, provided it's a negative slope. So the negative sign just tells us if it is either increasing or decreasing. So when you have the negative slope, it's just telling you if the y value is going to increase or is going to decrease for every unit increase of x. So that's the second case. And then the third case is when we have an undefined slope, where so it's going to look like this. If this is your y-axis, this is your x-axis. So an undefined slope will be a line that is vertical, or that is perfectly vertical, or we can say parallel to the y-axis. So this is an undefined, it has an undefined slope. Take, for example, you want to compute the slope here. And so we have 2 points. And then this could be 0.2, this is 1, and then we have 1 here and then 2 here. So to get the slope, remember that we have our rise all over our run. So our rise is 1, but our run is 0 because it did not move either to the left or to the right. So that is 0. So it becomes undefined because anything you divide by 0 gives you an undefined fraction. I mean, it's if you even punch that in your calculator, it's going to give you a systematic error or sometimes return undefined depending on the programming of your calculator. So this is the second case. The fourth case is where we have a slope of 0, and in that case, your line is parallel to the x-axis. So if this is your y-axis, this is your x-axis, and then you graph your straight line. For example, your straight line is y is equal to mx plus c. But in this case, when you graphed it, you saw that it is just parallel to the x-axis. This is going to give you a slope of 0. Now we can also demonstrate that further by taking 2 points, say this point and this point, where this could correlate with say 1, and then this is 2. And then on the x-axis, this is, let's say 1, and then on the y-axis rather, this is 2. So to get the slope here is going to be rise, but there is no rise here. It did not rise, but there is a run. So the rise is 0. So m is equal to 0 divided by the run, which is 1. So 0 divided by 1 is equal to 0. So this is the fourth case. So the case 1 is when you have a positive slope. Case 2, you have a negative slope. Case 3, undefined slope. Undefined slope. And then the fourth and last case is where your slope is 0. Slope equals 0. So these are the 4 cases. I trust that these answers your question. I think we have another question. Good. Okay, I think, do we have any other question? Please feel free to ask questions if you do have. Thank you so much for that wonderful question. I believe that a lot of our audiences and participants have been able to also learn from that with the explanation provided. Thank you.
Yeah, thank you, Mr. Chinon. So as we begin to wrap up, we only have about 7 minutes for today's event. I'm actually going to wrap up the live stream, so we'll be back again tomorrow. I do want to provide an update on the time. We'll be starting at 12 p.m. Eastern, 5 p.m. Nigerian time, 7 p.m. Kenyan time. And it seems like you guys went through for about 2 hours today. Thank you, Mr. Chinonso and Mr. Michael. We'll probably have some other guests as we go. And our goal is quite simple. Every child reaching their full math potential. Every child, no matter what your story, no matter where you live, if you have internet access, pencil and paper, let's help you go to the next level in mathematics. So we have different programs that we offer year-round, tutoring services. We partner with tutoring organizations. We look forward to introducing you to some of the organizations that we work with. But we want every tutoring center to have the resources to give their children mathematics from counting to calculus. And so please visit our website, countingtocalculus.org, countingtocalculus.org. You can visit our website and learn more about what we are doing. Lastly, starting tomorrow, you can visit our other website called countingtocalculus.online, countingtocalculus.online, starting tomorrow. And it now has features such as diagnostic tests, adaptive learning, everything that you need if you want to use the app as well. So that is all live starting tomorrow at 8 a.m. Eastern time. So now I'm going to go back and stop the live stream on YouTube and then give us like 5 minutes to have an interaction with those in the actual webinar, if that makes sense. So let me stop the live stream, and then if you don't want to chat, that's fine. But those who want to talk, you have the opportunity to ask questions.